Only one of his targets on Twitter, so if you want to see some funny stuff, check it out. All right, what time we got? Okay, so we'll shift gears into row rice just a little bit. I guess we'd all agree that that's a pretty common topic today and tomorrow. So we'll just dive into a little bit of what we're looking at in Arkansas. One thing I've put together a little bit on, we do a county agent survey at the end of every year for rice production. That's really built upon, questioning growers in their counties and everything to get those numbers. So that's where it comes from, but to kind of paint the picture of where we are in terms of irrigated rice adoption over the last several years. So going all the way back to just a few thousand acres in the 12, 13, 14 range, and then this dramatic uptick. Even in 17, it was a percentage increase. We went down in total acres, but the percentage increase continued to go up. So now we're staring at somewhere around 150,000 acres, or very close to it. Actually hadn't gotten everything in on this survey, so it could be a little higher. As if we potentially get acres up again this year in 2020, obviously that number I expect to climb even more dramatically if we hit that number with 1.1 million acres. If we do 1.4, 1.5 total acres, we're probably going to clear 200,000 acres of irrigated rice this coming year. So again, just a little historical thing, depending on your perspective on row rice, your level of excitement there. But again, so getting up to large acres, the main thing about it is it's absolutely working in a lot of different situations. Even as we were first easing into it, trying a field here and a field there, we quickly began to figure out that it actually can work in a lot of situations that we wouldn't have necessarily always thought that it would. The biggest hurdle to get over is usually the fact that, you don't have to have a flood to grow rice. You gotta have water, but you don't have to grow it in a flood. So again, kind of a right place at the right time thing, but there are still those places where we're gonna extend just a little too far, or in just the wrong location where we can't manage it to the extent that we need to. And again, we've done a little work in all of those fields, good, bad, and otherwise, and we'll share a little bit of some of those details. If you've caught some of my talks and others at crop management conference last week and things, some of you have seen some of these slides and comments that I won't spend a huge amount of time on, but emphasizing, as others have, not getting the beds too tall. We do say furrow irrigated rice, we don't say bedded rice. You don't have to have a bed to do it. Even like the 75-acre field that Scott was referring to, that one's one you might want to have a bed on because it runs from corner to corner. I've got side slope. Okay, now I need some bed formation more to keep the water in furrow, but on straight levee, maybe it'll come back. Single direction fall, drill flat. And we've got guys using, various implements, some they built themselves, to just pull a little water furrow just to convey it down the field. The biggest thing is I'm hoping to wick water laterally instead of asking it to wick up to a big tall bed. If I go put row rice on a big cotton bed, I've lost from the time I put it in the ground. I will never get it to the top of that bed, and I'll end up with a mohawk heading of rice that's not going to make anything on the top. So again, kind of the main thing we want to avoid there. Using pipe planter or rice irrigation app to set that up, still going to be a huge advantage for us. Again, reiterating some things, surge valves, in blocking where it's appropriate, backing water up, and hitting those critical timings, whether we're talking irrigated rice or alternate wetting and drying or anything, avoiding, if any other time, avoiding having a moisture deficit stress situation around joint movement, and then again at heading and beyond, which is when we've really got to be on top of it. And then we still don't have a huge amount of actual work or dedicated research on that last irrigation timing, which is it's a hard one to chase, just like drain timing in itself is a very difficult one to chase. But as a rule of thumb, irrigating one more time potentially after you normally drain, the steeper the field, the more true that's going to be, because you don't have a full profile, and it's going to dry down very, very rapidly, again, especially at the top of the field. Flatter the field, yeah, you might be keeping a fuller profile and maybe be in a little bit better shape. But something, again, not just Justin Klepechka, PhD student for myself, and Trent Roberts is in here, and I'm going to let him comment on a few slides from some of his research here in a minute. But something even Dr. Chris Henry and I have discussed is, utilizing Watermark sensors as an added tool to help guide your efforts in timing those irrigations, and maybe relying on a shallow sensor, but having the additional deeper sensors in there again to have an idea of what's going on beyond the most shallow part. If you're familiar with the Instar program, again, nitrogen soil test for rice, the soil sampling depths for those are 18 inches on a silt loam and 12 inches on a clay. Why are we sampling that deep for nitrogen? The roots go that deep. Okay, yeah, so we can get that deep. Not in every situation, and I don't think I want to necessarily ask a rice plant to have to go down to 18 inches to get water in that scenario, but we know that they go that deep to pull water, so we can do some things. Intervals on these, 3 to 5 days or 5 to 7 can definitely be extended beyond those windows. That's a very conservative number. Again, with some other work I'll comment on in a minute, we've shown that can again be true. We still generally are recommending the hybrids kind of as a group. You see, I'm not trying to list every possible thing you could go get in this table, but stress tolerance and obviously blast resistance playing a huge role in that recommendation. It'll come back. Keep going. The use with caution, a little bit more has to do with, again, even the CLL15 and CL153. They have some blast resistance. It's not complete. And being smaller plants, little smaller root systems, things like that, again, just got to be a little bit more careful where you put those and having adequate water. Jupiter and Titan may seem a little bit at odds with some folks because they're blast susceptible, but they have more of a tendency for leaf blast, highly manageable, and less of a tendency for neck blast, very difficult to manage. So we've actually seen very good success at the field scale, even very large field levels, particularly with Jupiter in that situation. And Jupiter would even still be my preferred of those two. Again, just a little bit longer season, a little easier to manage. And then you start getting into stuff that's more and more blast susceptible and stuff like that down the list that we kind of shy a little bit more away from. This is actually from small plot work, and the reason for showing this small plot data for top and bottom of field is to show you what happens at the top end of the field when you mess up. Is really the take-home point. So on the left side, you can see the top end, and on that one, that was a silt loam soil situation where no matter what was changed, those beds would not wick across. No matter what. Laid new pipe, changed hole sizes, did everything. It was done right the first time, but it still wouldn't wick, so we tried everything. Would not wick. Guess what? Lost nitrogen, plants were stressed, it couldn't change anything. Pretty good yields at the bottom that stayed saturated and flooded. Top end of the other field was on farm. Horrible herbicide injury. Just hammered it. We didn't think it'd ever recover and make much of anything. I was happy it cut anything. But again, the issues you can run into. Obviously, we did 2 sites, got 2 major issues at both of them. Successful year, right? It's the way it goes. Still recommending and emphasizing seed treatments. Cruiser Max and Nipsit are going on most things. Gus Lorenz and Nick Bateman have been focusing on, guess what? There's not enough on that seed yet. So what can we add to it? And in a row rice situation with bill bug potentially, that's that little grub in that picture. Maybe there's something there, but Dermacore or Fortenza may be what's necessary to bring those under control. Still a lot of work in that regard, but that's one of the bigger questions out there. Just a couple of really hard hit fields from rice bill bug this year, and we're actually learning a lot about that pest biology and finding out that we actually don't know much about its biology. It behaves pretty strangely as far as that type of pest goes. General fertility, Phosphorus is our main concern right now. We have and haven't seen deficiency issues. Justin started a little survey work this past year. I don't have any data to show on that yet. We're literally still getting in those plant samples back even this week for all the fields that he did, trying to pick up some of those differences in uptake between top and bottom, where we may need to differentiate a little bit of our base fertility for it. But again, we're not going to have as much phosphorus availability in a non-flooded situation, so we're going to try to be careful there. But beyond that, not a lot changes. And time is it? Justin, you want to come up and talk for just a minute about some of your nitrogen stuff? We got about 10 minutes, something like that. So don't take all day. I'll just be right here.
Yeah, clicker.
No, just hit the down button or the on button right there.
All right, so I'm appreciative to have been working on this for the last couple of years. We've had a total of 7 silt loam sites and 4 clays that we've looked at over the past few years. We intend to do more this coming year also. But just giving a run through on some of these sites, looking at last year, one of our clay sites, you can see here that we've got, we did these different splits, and it was anywhere from a single pre-flood application up to a 4-way split that we did. Most of them were generally based on that single pre-flood recommendation for the specific situation that it would be in. But we then also did some additional nitrogen work. And we really saw, especially on these clay sites, that whenever we got into these 2 or 3 or 4-way splits with the additional nitrogen, that we did see a yield increase. Thank you. Yeah, so we can see, especially with this site, we had an excessive pre-flood rate of, it'd be 210 pounds that would also help to optimize yield, but that would not work in all situations, in all cases. This particular site it did, but it didn't always work that way. So what we saw is really a huge standout that we had both in the top and bottom of the field was a 3-way split that included an additional 100 pounds of urea. So it'd be a total of about 196 units of nitrogen that would be on that. Yes, ma'am.
How did you define what was the top? How much of that area? How big was that top and the bottom?
Oh, we just defined the top and bottom by generally the top was the upland environment, and these were small plots.
Oh.
So that's how we easily got them all in there.
Yeah. So the top end, the test is located in the upper 1/3, and then the bottom was in the bottom 1/3. So we got out of the gray area in the middle and more the 2 distinct areas.
So then just moving into this past year, we can also see pretty much the same trend. We didn't have differences in top and bottom. It is actually pretty similar across both ends of the field, so we combined those here. But you can see again that treatment that had the additional 46 pounds of nitrogen really stood out for us and yielded, almost 250 bushels an acre on a plot setting.
Go ahead and point at those 2 you're referring to for them, the additional 46.
Oh, sure, yeah. So
yeah, that one versus where you didn't put the extra 100. Same treatment, but without 100.
Right, yeah, the same treatment. You see it yielded about 220 bushels as opposed to almost 250. So we get about at least a 25 yield bushel increase on that. Yes, sir.
Timing of them, because you say 75 is 0. What's the one?
Yes, so that 0 would be like a week in between. So the 75 is 4 to 5 leaf stage. Then that 0 would be the next week. Then we put out another 75, which would be 2 weeks after that first application.
Is it joining, green ringing at that 75?
By about that last shot of the 46 pounds, it's about green ring.
Okay.
So it'd be about 3 weeks apart from that first nitrogen application. Yes, sir. So then also moving into some quality data that we looked at, milling data. Our head rice yield also last year, this is the top is the white bars, and the bottom of the field is the blue bars, which would be flooded. We can see that the bottom of the field did consistently mill higher than the top of the field, which is what we would expect. The main reason for that's being because we're just having less harvest moisture at the top of the field. That bottom of the field is going to mature later, and so by the time we get out to harvest, it's just going to be drier at the top of the field. That's the main reason for that. But we can see again that treatment where we had the 3-way split with the additional nitrogen, we can see again that it's out yielding as far as head rice yield also. Just looking at some silt loam data, this was a site from 2 years ago, 2018. We can see again that the bottom of the field, as long as we got that nitrogen out, it didn't really matter what scheme we used. We could optimize the yield at the bottom of the field. But however, at the top of the field, we definitely needed a 3-way split or up to a 4-way split to optimize the yield at the top of the field. And you can see again, this treatment with the additional nitrogen was one of our top yielders. So looking at another site this previous year, you probably think that I messed up the data here, wondering what the bars look like. So what this is, you can see obviously the bottom end of the field yielded very well as you would generally expect. However, the top of the field was one of those that seals over really bad that Jarrod was talking about earlier. So we ran some of these irrigation sets upwards of 50, 60 hours and still on 30-inch middles and still couldn't get the beds wicked up. So we looked at the yield monitor of the farmer, and then we also looked at our plots, and it averaged anywhere from about 140 to 150 bushels at the top of the field. And that's with a hybrid 753. So what we want to emphasize there is that you need to make sure that you can somehow get the water to wick up across those middles. And if you're not going to do that, you're going to see the Mohawk effect, and you're going to see obviously the huge yield differences that we got here. With that, I'll hand it back on.
All right. So, said Justin's been working on that for a couple of years, and we're still not done. There's still questions within that. Even some of the bad sites have still told us something. That last one, the field yields matched what we got in the small plots. We had splits going on the entire rest of that field, and it was 220 dry at the bottom, and it was 140 dry at the top. So again, it didn't matter. It would not wick. Some flatter fields that had a little better success adjacent to those where we didn't have plots, we were getting those to wick, and those actually yielded consistently a lot higher and did a lot better. But we've also done some large block work, and when I'm saying large blocks, I'm referring to 20 plus beds wide, and in the case of pine tree, about 800 feet long. So again, a pretty good run, and again, replicated. And so in 2018, no matter how far we kind of let the moisture go, and none of it was too drastic as far as moisture deficit, but we were able to equal the flood in 2018. And 2019 should be a big problem for anybody looking at that type of loss. The problem in 2019 was about the time we needed to fertilize and go to flood. The pilot quit. He retired. And so we found somebody that'd fly urea, and they'd do it one time. So we flew that one big shot up front. Guess what? I'm 30 bushels off, which based on Justin's data is exactly what I should be off by not splitting my nitrogen up and what I lost. So didn't mean to have that kind of data to back up the other, but sometimes serendipity is a part of doing some research. And again, large scale, if you dig within head rice data as we have with Justin, you'll see some of those trends at top and bottom. But at the end of the day, we usually end up with fairly competitive overall head rice yields when you're averaging the whole field area together. It's not always a drag. And we can have some substantial water savings when we start to stretch these irrigation events out, and again, using some type of sensor to help you out to make sure you know that rainfall actually gave you some bed saturation or it didn't. Whatever, again, just to help guide that conversation. And the same thing again was true in 19, even with the rains we got. Again, depending on the times they fell, we actually ended up irrigating even a little bit more, shockingly, in that situation. But we could still, again, even though we were down on all those yields in 19, like I just showed you, there weren't any difference in the yields between those three thresholds. And I could have saved a ton of water by backing off there. And then if I'd have split my nitrogen right, Scott, I guess I'd have probably been okay. And that was all silt loam soil at Pine Tree, and then at Kaiser, a pretty similar story in 2018. Again, another situation of serendipity. So this time we ended up, unbeknownst to us until we called the plane, a corn fertility test right up against the field. So we flew one time and called it done. Guess what? Gave up 25 bushels. Then this past year, we said, don't ever put anything like that near us again. We did a three-way split as we prescribed, and we actually improved the yield on that field pretty substantially compared to the flood. So again, going by that split for clay soil that has been standing out for us as a treatment has shown pretty good. But I only throw this head rice data slide in. This was 2018. Anybody else have any problem getting rice out of field in 18? Little? Lot? Yeah, us too. So it sat there for probably a month after it was ready. And that top end, that's the run average. That top end was, I don't know, something they say, well, it's pet food. There's some things pets won't eat. So it was pretty bad. So again, even similar argument on the water use. Again, we can continue to stretch that out and reduce our water use, still not seeing yield losses. And again, in 19, that Mississippi River Ridge area, I saw rainfall after rainfall actually miss that Mississippi County area this past year that was catching everybody else in the state, and it really didn't rain as much as you'd think, so we ended up actually pumping a lot to keep the flooded rice flooded, and on the furrow-irrigated rice, worked extremely well, even irrigating frequently on a very short leash there. We still reduced dramatically the water. Few other comments. I'm sure we're done. So anyway, using pre's, having the ability to roll out pipe and irrigate and activate those pre's in some of the weediest years, we've seen the cleanest fields be row rice fields. I'm not going to get into, said I had a few of these I thought were extras. I think I woke everybody up with a joke a while ago, but we'll kind of wrap up there. And if you've got any questions, I know we're at the end of time, but anybody got anything for me or Justin, or even another one for Scott? Mike, you still?
Why do you think the 3-well is doing better than 4 times 100 shot?
Honestly, it's primarily probably that upfront shot that you're getting incorporated before you ever put water across the field. Just that one being bigger. And when you go back to, again, you're really close on some of the other ones that have anywhere near that largest shot up front, but then that extra 100-pound kicker at the end just kind of seems to be what brings it home. But that, 46 unit, 100-pound urea up front, just seems like we need to be incorporating more there with that first one. Yeah. That's it. Thank y'all. Have a good one.